The de Havilland DH.60 Moth, 1930. A London secretary named Amy Johnson climbs into the front cockpit of G-AAAH, a machine built from wood, fabric, and wire, and points it toward Australia, 11,000 miles. No radio, no autopilot, no safety net of any kind. She makes it. That flight did not happen because the Moth was forgiving. It happened because she was not. This aircraft does not assist you, it does not warn you, it does not correct your mistakes. Every input you make is direct, mechanical, and permanent. So the question this video answers is simple. What does it actually take to fly the DH-60 Moth, and does the modern pilot still have it?
The DH-60 Moth first flew on 22 February 1925, piloted by Geoffrey de Havilland himself at the company's works airfield at Stag Lane. It's a two-seat biplane developed from the larger DH-51, and by any structural measure it is elementary. The fuselage is plywood over a wooden frame. The flying surfaces are fabric. The whole aircraft is held together by wire, wood, and a level of engineering honesty that demands respect. There is nothing here that conceals what it is. The dimensions are compact and deliberate. Length, 23 feet 11 inches. Wingspan, 30 feet. Height, 8 feet 9.5 inches. Empty weight, 920 pounds. Maximum takeoff weight, 1,650 pounds. That is a workable payload margin, but not a generous performance margin. Every pound you add is a pound the G-AAAH engine must move, and the G-AAAH engine is producing 100 horsepower, nothing more. The wings fold. This was not a cosmetic feature. Geoffrey de Havilland understood that private ownership required a machine that could be stored in a standard garage. Folding wings expanded the ownership pool. The lower main planes carried de Havilland's patented differential ailerons. The upper wing has none. There are no flaps, no slots, no mechanical lift augmentation. The pilot manages energy entirely through airspeed and attitude.
The fuel tank sits in the center section of the upper wing, bulging slightly into the airfoil profile. It feeds the engine by gravity. There is no fuel pump, no low fuel warning, and no mechanical recovery from an empty tank. The propeller is a two-bladed fixed-pitch unit, one blade angle, one compromise between climb and cruise. The pilot cannot adjust it. They must fly within the envelope it defines. The exhaust runs along the left side of the fuselage beside both cockpits. The tail is a single fin and rudder with a horn-balanced rudder on production aircraft. Earliest variants carry no trim tabs. The pilot holds attitude, the aircraft does not. The undercarriage on early models is a single-axle fixed arrangement with a tail skid and no wheel brakes. Ground directional control is managed through rudder and engine power alone. By 1929, an estimated 85 out of every 100 aircraft in Britain were Moths. The machine had become the environment.
Two open cockpits in tandem. No door, no canopy on the standard aircraft. Canadian variants were offered with a detachable canopy for winter flying, the only concession in the design to environmental discomfort. In the standard Moth, the outside world is where you are. Temperature, wind, and engine noise arrive directly. The instrument panel is minimal. Airspeed indicator, altimeter, engine RPM, oil pressure. No artificial horizon, no directional gyro, no radio, no electrical system on early variants. Navigation is by map, compass, and ground reference. There is no carburetor heat warning. There is no fuel quantity gauge beyond a float check in the upper wing tank. If the pilot does not manage fuel state, the engine stops. The aircraft does not ask them to reconsider. The engine is hand-propped. There is no starter motor. The pilot stands in front of a live propeller, sets the throttle, and swings the blade through compression. It requires a specific sequence, a clear understanding of engine state, and discipline. A mismanaged hand start in a brakeless aircraft has no safe outcome. Forward visibility is limited by the upper wing and the engine cowling, standard biplane geometry, not a design flaw. On approach, the runway ahead is partially obscured. The pilot uses a curved approach path or a controlled side slip to maintain visual reference. That technique is not optional. It is required by the aircraft's structure and must be learned before the first solo. The DH-60 Moth trainer introduced the specific modification in 1931. The inner wing bracing wires were rearranged to allow easier front cockpit access for a pilot wearing a parachute. The original layout made emergency egress difficult under those conditions. That change was a direct response to a documented safety constraint, not a refinement.
Control forces are direct and unassisted. The pilot feels everything the aircraft feels. When the wing approaches a stall, the buffet is real and immediate. There is no stick shaker, there is no warning system. The aircraft communicates through feel, and the pilot must be trained to read it. The Moth does not remove tasks from the pilot. It assigns all of them.
Maximum speed 102 miles per hour, cruise speed 85 miles per hour, range 320 miles, service ceiling 14,500 feet, rate of climb 500 feet per minute at sea level. These are honest numbers. What they do not show is the margin, and in the Moth, the margin is the entire story. The gap between cruise and maximum speed is 17 miles per hour. There are no flaps. There is no way to steepen an approach without adding speed, and no way to shed that speed at low altitude with 100 horsepower. A high and fast approach must be solved before the threshold, not after. The climb rate of 500 feet per minute degrades with altitude. The fixed-pitch propeller cannot be optimized for both climb and cruise. Terrain clearance over elevated ground is a calculation, not an assumption, and it must be done by hand before engine start. The 320-mile range is functional. It is not generous when the only navigation tools are a paper chart and a compass. Amy Johnson flew G-AAAH from England to Australia in May 1930, 11,000 miles across 17 days, each sector planned by visual waypoints and dead reckoning. Mary Bailey flew a Cirrus Moth solo from Croydon to Cape Town in March 1928, 3 weeks in an open cockpit with no navigation aids. Francis Chichester flew England to Australia and across the Pacific toward Japan before a crash ended the attempt.
These were not exceptional flights because the Moth was exceptional. The range is 320 miles. The cruise speed is 85 miles per hour. Those numbers did not change. These flights were exceptional because the pilots were. The Moth did not carry them, they carried the Moth. On the ground, the absence of wheel brakes on early variants means the pilot manages every meter of the takeoff and landing roll through rudder and engine alone. There is no differential braking. There is no nose wheel steering. In a crosswind, the aircraft weather vanes toward the wind if the pilot does not anticipate and counter it continuously. The tailwheel skill set that modern training largely treats as a specialization was, in the Moth, simply what flying required. The RAF initially found the Moth unsuitable for military training. By 1931, they had acquired 124 DH-60M Moths and operated them until 1939. The military eventually reached the same conclusion the flying clubs already held. The demand level was not a deficiency, it was the point. A total of 1,535 DH-60 Moths were built by de Havilland in Britain, Morane-Saulnier in France, the Moth Aircraft Corporation in the United States, the Norwegian Army Aircraft Factory, and multiple manufacturers in Australia. The aircraft served over 25 air forces worldwide, from the Royal Air Force and the Royal Australian Air Force to the Swedish Air Force and the Chinese Nationalist Air Force. The oldest surviving example, GEBLV, built in 1925 as the 8th aircraft off the line, remains airworthy today at the Shuttleworth Collection in Bedfordshire. The DH-60 Moth is not difficult because it is flawed, it is difficult because it is honest. The 102 miles per hour maximum speed means energy management on every approach. The 500 feet per minute climb means terrain clearance is never assumed. The 320-mile range means fuel discipline is continuous. None of this is accidental. It is what the design requires.
Does the DH-60 Moth demand more from its pilot than any comparable aircraft of its era?
And is that demand the reason it succeeded? The answer is yes on both counts. It demanded more because it gave the pilot everything and filtered nothing. It succeeded because that demand produced pilots who could navigate, manage energy, handle the ground, and fly with precision that no automated system had built for them. The flying clubs that the Moth equipped trained the pilots who flew the next war. The Moth did not just democratize aviation, it set the standard for what a pilot was supposed to be. If you're flying one today, nothing has changed. The fuel is still gravity-fed, the propeller pitch is still fixed, the runway is still below the upper wing on final approach, and the hand-propping sequence still requires discipline. The Moth does not know what year it is. It only knows what you do. Thanks for watching. If you enjoyed it, please like, subscribe, and hit the notification bell so you're first to know when the next one lands.